Okay, cool. It's 5 past now, so we'll begin. So, hello everyone. Thank you for joining our webinar on robot design and sponsorships. Okay, so first of all, who are we? So we're Norwood Industries, a fourth-year FTC team made up of 6 students from the Norwood School in South London. And here are a list of the awards that we've won over the years. So in Freight Frenzy season, we were the division finalists and Motivate Award winners. And then last year in Centre Stage season, during qualifiers, we were the Winning Alliance captain and Control Award winners. And then we managed to advance to Champs, where we were the Winning Alliance and Design Award. So here's what we'll be covering today. Firstly, the importance of CAD, and we'll be giving you a number of tips and just tips to improve your CAD. Cable management, and then in the second part, Rupert, who's on my team, will be taking you guys through our sponsorship template. Cool. So we'll begin now. So first of all, what is CAD? So you might not have ever heard of CAD. So CAD stands for Computer Aided Design, and it's a software which you can use to digitally create a robot before you actually bring a robot into fruition in real life. So firstly, there are quite a few important things with CAD and advantages to it. Firstly, you can have more efficient packaging, which we'll cover later. You can avoid part collisions before you actually build your robot, and you can create custom 3D printed parts and test before you actually build your robot. So what is packaging? So packaging is how effectively and close together you arrange all of the parts in your robot. So as you can see below, we've got our current robot design, and you can see that we've gone for quite tight packaging. So quite a lot of the motors are right next to each other. So here are some examples of packaging which we think are both good and bad for different reasons. So in this first image, you can see our center stage robot. And the reason we didn't like this one as much was because everything was quite spaced out, and we had a lot of dead room where you couldn't really put any components, but it was taking up space, which overall just made our drive chain really big. So we were 17 by 16 inches, which is quite large. And then last year, we were really ambitious and we tried to make our robot just as small as possible. However, this was also bad because we didn't have enough space for things like wiring and place the part of control hub. So as you can see, our motors were right up against our frame, which meant that when we came to actually wiring them up, we had quite a lot of trouble doing that. And then on the right, we have our robot from this year. And we think that this is really good packaging because we had a good balance between having enough space for additional components like wiring, but also our robot was fairly small, being 12.5 by 12 inches. The next advantage of CAD is avoiding part collisions. So unfortunately, within a CAD software, sometimes you can accidentally make parts kind of intersect, so they're occupying the same space. But luckily, there are tools that can help you prevent this. So in Onshape, which is the CAD software that we're currently using, there's a tool called interference detection. And when you enable it, it will highlight in red all of the places where parts are too close together. So if you look on the right of my screen, you can see there's that red servo, and it was like touching the control hub, which is obviously a problem because when you come to actually build your robot in real life, parts won't be able to fit where they're supposed to. Next advantage is modeling fasteners. And what I mean by fasteners is things like nuts, bolts, spacers, all of those small things which you might not think about until you come to actually build your robot. And it can be helpful to model in fasteners. However, it's not always necessary, and we'll cover a few cases where this is necessary. So fasteners can be really useful in tight assemblies where there's not much space and you need to instantly be able to see if things are going to collide. However, in assemblies where there's plenty of space, you don't necessarily need to model in fasteners. So here are a few examples. On the left, I've got a case where it is necessary to model in your fasteners. So this is on our deposit system. And you can see that there are quite a lot of parts really close together. So it was important that we were able to model in the fasteners and check that everything would fit before we actually came to make it. And then on the right hand side, you have our outer plate of our drivetrain. And in this case, we chose not to model in fasteners because there weren't any additional parts that needed to go there. So there wasn't any chance of collision. So it was fine that we didn't model in the fasteners. And the next advantage is making custom parts. So on the bottom of my screen, you can see we've got quite a few custom parts which we've designed, and then later on we 3D printed. And there are loads of benefits doing custom parts, and it's something we really highly recommend. So first of all, you can combine parts, reducing failure points. And by failure points, I just mean if you were to have an assembly with, let's say, 50 parts, you have 50 different parts that could fail. But then if you were able to combine them into 5 parts, you would only have 5 different parts that can fail. So overall, your robot would become more reliable. And then another advantage is reducing part cost. So quite a lot of the time, you can buy parts online, but it's always cheaper to manufacture your own. And then another advantage is custom dimensions. So for example, if your team is using the Rev or Go Builder drivetrain, you might know that they have an 8mm grid spacing. However, let's say you wanted a hole which is 4mm away, you wouldn't be able to do that. So being able to design your own parts is really helpful. So here's an example. This is our linear slide assembly, which we currently have on our robot. So we were initially going to just buy the pre-built Go Builder linear slide. However, we decided against this since there were quite a few unnecessary parts which we thought we could cut out. So instead of buying all of these parts, we chose to design a single 3D printed part which combines all of them. So in this one 3D printed part, we have our motor, channel, linear slides, sensor, and this also helps us mount the actual linear slides to our robot. And the final advantage of CAD is testing before assembly. So what I mean by this, for example, if you didn't CAD your robot, you wouldn't necessarily know if, let's say, your robot could reach to the high bucket or hang successfully, which could be a problem because you might fully build your robot and then figure out it can't even score points, which would be a problem. So in CAD, you're actually able to import the game field from the Andy Mark website, who are the company that make the game field. And then you could import your robot and then just check that your robot could, for example, intake a specimen from the wall or deposit in the high bucket. So now that we've been over all of the advantages of CAD, it's now important to choose your own CAD software. And this will vary from team to team depending on, for example, how many people you have working on the CAD and like your overall needs. So we got 2 CAD softwares here, Onshape and Fusion 360. So Onshape is the one that our team is using, and we really like it because, first of all, it's cloud-based, which means you don't actually have to download the software. Onshape is just a website which you can access through any browser, which means that you don't need a good computer. So if you're, let's say, working on the CAD in school on the school computer, you don't necessarily need it to be a really great computer to access the CAD. And there are loads of community add-ons. So on our robot, we're using a tool in Onshape called Lighten Tool, which allows us to cut material away from our parts. And that was designed by someone else. And it was really easy for us to just add it into our Onshape document and use it. However, there are some disadvantages. Firstly, it requires a really good internet connection. So even if you have the best PC in the world, if you don't have a fast internet connection, Onshape won't run as well. And also it can be laggy at times, especially if you're working with a really large assembly. And then the second CAD software we have here is Fusion 360. And the main benefit is it's really powerful. So I think it's one of the oldest CAD softwares in the world. So it's got a lot of new features, which other CAD softwares don't necessarily have. And it's got quite a lot of advanced features, which Fusion 360 doesn't have, which Onshape doesn't have, sorry. Like a built-in CAM suite, which is for actually manufacturing your parts. However, it does need you to have a really, really good computer. So that can be a problem for some teams. And also sharing files can be difficult. So before we continue to the next section, does anyone have any questions? You can just read them out or put them in the chat, that's fine. Cool. Yeah, we can move on if no one has any questions. So the next part that we're going to be covering is wiring. So this is like connecting all your motors, servos, and sensors to your control hub effectively. And there are a number of things that we're going to be covering. Firstly, protecting your cables, because quite a lot of the time your cables might just be loose in your robot, and then they could theoretically get caught up in, let's say, a drivetrain, causing them to break. Preventing disconnects, so preventing the connector itself coming out of the control hub, which would leave you dead in the water. And then finally, labeling cables, because once you start building really big and complex robots with a lot of motors and servos, it can be difficult to keep track of which servo is which. So firstly, protecting your cables. So on screen, we've got 4 different choices for attaching your cables together and keeping them neat. Firstly, we have zip ties, and as you might know, they're really cheap and really easy to use, which is a benefit. However, they don't actually protect your cables, so even if they were zip tied together really well, it doesn't stop something from coming and chopping them in half. And also, they provide quite little support, so you might zip tie it like every 30 centimeters, let's say, but then in the middle of your cables, there's still a chance that they could come apart. And then this one, the number 2 cable protector, it's a braided sleeving. So you can buy these on Amazon in, I think, 5 meter lengths. And it's basically this flexible tube which you can unwrap and insert your cables into and then close it up. And these are fairly cheap and quite easy to use. And they're actually what our team uses to organize our cables. But they can be quite floppy and loose, which would cause them to like move about in the robot where you don't want them to. So it does require an additional mechanism to hold on to them. And then the the cable protector number 3, it's called a cable chain, and it's basically a flexible, it's like a mechanical flexible sheath which you can insert the cables into, and then it's able to only bend in one direction. And the benefit of this is it's very protective, so you don't need any additional kind of support. And however, there are some cons. Firstly, it uses quite a lot of space and it has quite limited reach, so you have to be able to coil up the cable chain whilst you're not using it. So if you had a really long length of it, it can get quite bulky. And then on the far right, we have a scissor lift, and this is a mechanism. It's basically a bunch of bars attached together in a crisscross shape, which allows them to extend. And then what you do, you zip tie or maybe use braided sleeving to attach your cables to the scissor lift, and then this could move in a linear motion. So, for example, on your linear slides. However, there are some cons to it. Firstly, it requires quite a lot of space. So, for example, on our robot, we have an entire part of the back of our robot, which is it has like no motors, no mechanisms, just for the scissor lift. And also, they can be quite expensive because you've got to buy all of those different bars, especially if they're coming from like Go Builder, where you have to get it shipped over to you. And then next, another important thing to consider when doing your wiring is preventing extension disconnects. So on your robot, if you've got a really long wire, you might have found that you needed to use extension cables, which you can like plug 2 cables together to make it extra long. However, you might have found that these can sometimes come unplugged, which can be a problem. So we have a couple of solutions to that. Firstly, you could use electrical tape, which is the cheapest and easiest solution. And you basically just wrap it round where the 2 wires join. And this would just prevent it from coming disconnect. However, at times it can be quite weak. So another alternative is using heat shrink tubing, which you have on the right. And it's basically this kind of rubbery tubing which you slide over your connectors, and then you can use a heat gun to like you use a heat gun, and then the tube shrinks down onto the cable. And these are really, really strong, and they're very low profile, as you can see. However, they can be quite expensive because you need to buy an additional heat gun, and they can be quite slow because you need to be able to individually slide on a piece of heat shrink onto every single wire, which can take quite a long time. And then preventing control hub disconnects. So occasionally you might have a wire just get completely pulled out of your control hub, which can be a problem. So we have two solutions to this. Firstly, you can use hot glue. If you just put like a bead of hot glue along each of the connectors, this can it has like it temporarily prevents them from coming out. And you can see we've used it here on our LED controller. And then also another important thing to keep in mind is making sure your cables always have a lot of slack. And a way to ensure this is by adding a service loop. So a service loop is basically a loop in your wire and then you tape it down, which means that if you were to accidentally pull the cable really hard, it would have plenty of slack and it wouldn't just come disconnected straight away. And now we're moving on to labeling, which is quite important. And there's a number of reasons why. Firstly, it's a lot easier to wire up your robot, so plugging all of the wires into your control hub if you've labeled them. And then also, if you were to have an accidental disconnect, which we hope you don't, it's easy to see exactly which cable has come out and why your robot's not working. And then it's also really easy to know which cable you have to replace if you've already labeled it. And also, it prevents incorrect connections. So if you had selected in your configuration that a server is in port one, but then you accidentally put it in port two, your robot's not going to work. So by labeling it, you can straight away tell that the server needs to go in port one and you won't spend time troubleshooting. So there are quite a few methods for this. So firstly, you can buy like labels, paper labels, and then you could cut them out and then just write what the cable is and then tape it over the cable. And this is really good because they're quite cheap and fairly customizable. However, it can be quite time consuming because you have to individually write on what every single cable is, and they can be easily damaged because it's only paper. Another method is to use colored zip ties. So on Amazon, you can buy an assortment of zip ties in many different colors, and then you could create a key. So, for example, your claw servo could be a red zip tie, and your drive chain motors could be a green zip tie. And this is really great because zip ties are really, really cheap, and they're quite low profile compared to all of the other solutions. However, there are only a limited amount of colors that you can buy. So if you've got too many wires, you won't have enough zip ties to color code each individual one. And then if you're willing to spend a lot more money, you could invest in a label maker. So this is a really great tool where you can simply type in what you want your label to say, and then the machine will print out a label with perfect writing. And this is really great because you reduce any errors whilst handwriting it. So you might accidentally misspell something, but with a label maker, it's always like perfect text. However, label makers are really expensive. They can be about £100, and the labels themselves are quite large compared to other solutions. And then finally, we have heat shrink. So you can, with a label maker, you could buy additional heat shrink labels. So you can use a label maker to print on heat shrink what you want it to say. And this is what our team's currently using because the labels are really low profile. They sit really flat against the cable and they're quite strong, so it's not easy to rip them off. However, it's really quite expensive. It can be up to £200 and it's quite time consuming. Cool. Any questions before we move on to the sponsorship section? Yeah, we can move on if no one has any questions.
Cool. So I'm Rupert. I'm the outreach lead at Norwood Industries, and everything we've gone over so far are things that we really think that sets our team apart and makes us, I guess, us. But they're all really important things that are often quite overlooked. So the next thing we're going to be going over is our sponsorship progress. So our team has created a template that we use to provide a structured framework for other teams as well to effectively pursue sponsorships. It includes sections for identifying potential sponsors, crafting compelling sponsorship proposals, and effectively tracking and reporting on sponsorship outcomes. And we have this 17-page document available for anyone wanting to use it. And I'm sure we can put that in the chat now. Okay. The first thing you want to think about when considering a sponsorship is how you're benefiting the company or organization you're targeting, because a sponsorship is a two-way deal and it needs to be enticing to sponsors. So what two things that we've done, promoting our company logo on robot panels and our team shirts, and that's quite simple. It's quite cheap if you've got team branding. And you can also create promotional videos on your social media about the company's products. For example, our sponsor, Accu Components, provides all our fasteners on a robot, which we display for our social media. And social media is also a really great way to entice sponsors because it provides like credibility to your team, and it makes you a bit more than an email or just like some words in an email in a paragraph. So it might be tempting to start sending emails straight away to those companies that you want a sponsorship from, but it's critical to keep a structured approach to keep a record of the status and outcome of all your sponsorship opportunities. We keep track of the progress and responses from organizations we've reached out to in a spreadsheet, just a simple Google Sheet. And this way we can ensure we don't email a company twice and come off as spammy or just annoying. So the fastest way to reach out to companies is through searching online. To be more successful, try and find a company with a similarity or connection with your team, because this will make it more enticing and it might give that company more of a um, impact on your team. However, we've received the least responses through cold emailing, so it's important to be vigilant. For example, we've reached out to probably over 400 or 500 sponsors through emailing, and we've only received about 20 responses. And with that, we've got about seven sponsorships secured. Another way you can get search responses is through visiting local companies or businesses. A good starting point for this is if any company that you or someone in your team has relations to, as so it'll make it far more likely they'll want to support your team. Another thing that we've also done, which is often overlooked sometimes, is checking what companies have followed or liked your posts. This is a good sign that they're already interested in your team and will want to continue with a sponsorship. So some more tips on finding a company. Look for companies that have already sponsored other FTC teams in the past, or just other general engineering groups. These can be like Formula One teams, for example. Our team has found for experience that there are certain companies which yield success and some companies which should be avoided. For example, avoid large corporations like Apple and Google, because the people managing their social media and all their emails often have millions or thousands of emails a day. So it's likely that your email will just get unnoticed. Some teams have had success with this in the past, however, so you could give it a go. And we've already touched on this again a bit, but local companies or businesses, I'd really recommend trying to reach out because even if they're restaurants or garages, they're far more likely to provide support to an educational team like FTC. Okay, some tips for improving your impression in a company in an email. My number one tip for you is to just be concise because we've touched on this, but managers will go through thousands of emails a day, and if yours doesn't get to the point, they're just going to skip over it. Make it clear the benefits that you'll be providing to a company, and use images of your robot and link your social media for credibility, just to make sure you're more than a few words on a screen. Another thing that you can do is using a signature at the end of your email to look more professional. For example, you can see our one with our logo and a link to our Instagram and YouTube. This way, a potential sponsor can search about us really easily with those links, and it gives a bit more credibility and makes you look a little bit more official. And once you've secured a sponsor, it's important to directly update them on your progress as a team. This ensures that you continue the sponsorship into the next FTC season, and ensuring you can build up sponsors as you progress as a team. We recommend sending a quarterly email every 3 months, highlighting everything you've done in that period, which can be anything: outreach, building robot, and competing, and how their support has helped you. Include plenty of images of what you've been doing, which may be featured on your sponsor's social media accounts. This directly lets the sponsor know how their support has been helpful and that you wish to continue the contract. And that's it. Any questions? Cool.
Okay, cool. Thank you everyone for attending. And if you want to rewatch the webinar, or if you know someone who just couldn't make it to the live version, we'll have this recording posted on the Makerspace along with all of the slideshows and materials we used today.
Amazing. Thank you for joining, everyone. We hope you learned something. And it's been fun hosting this. So have a good rest of your day or night. And yeah.